Okay, so we're going to build these ATSC 3.0 transmission systems. We're going to incorporate them somehow into facilities that already exist and that need to provide all kinds of content into them. How are we going to do that? So what we're going to talk about is the integration into facilities, into the existing ecosystem, and what that ecosystem may become going forward. We had a number of objectives in doing what we're doing, or what we're still doing. So we'll take a look at that, the why. We'll look at what we've been doing, and we'll look at how we've been doing it. So this all began when there were some block diagrams requested by some of the other specialist groups to provide information on how the technology that was being developed in those other groups would actually be implemented in stations, so that that could be understood and the standards could be written appropriately for that. There was also a recognition that more such requests were likely to come, and so it was decided that there should be some modeling done to provide that information to the overall process. In figuring out what to do, we took as our model the top-down process that was done in 1998 for what we now call ATSC 1.0. That was done after the standard already existed, and we had to figure out how on earth we were going to take what had been created and fit it into facilities. This time around, we're trying to get ahead of the curve and help the standard actually be written in such a way that how it fits into facilities is a much more easy process. At the same time, we're trying to do this as quickly as we can to make the information available to the process as it moves forward. So the ultimate objective of the top-down process is to produce a series of block diagrams that characterize the system in terms of layers. And the layers have to do with different types of signals, different types of data that flow through the station facility and end up at an ATSC 3.0 encoder. What we decided to do was to create models that are not representative of any particular operation, but that would be close enough to all of them that somebody trying to build a facility or to integrate ATSC 3 into a facility would be able to say, okay, I recognize what's there, it's close enough to what I need to do that I can learn from that and have it help me do the integration that I've got to do. So we're producing a report that explains that ecosystem, and its intention, as I mentioned, is to aid the development of the standards, but also to aid the actual implementation once the standards are done, and ideally to educate the eventual implementers as to the things they need to be aware of. In the process of developing this, what we decided to do was to hold a couple of very intense meetings. Those meetings were divided into some plenary sessions that coordinated things, and primarily into breakout groups that were devoted to each of the various layers. One breakout group per layer. We used the plenary sessions not only to coordinate work, but also to look at the interlayer interactions and what we came to call touch points. So what kind of signal is going from one layer to another? How does it get there? Those kinds of things are what the touch points are. And then also where we had issues that led to disconnects between layers, we resolved those in the plenary. The breakout groups worked on the block diagrams, and I'll show you those in a couple minutes. So the development of the overall layering system was based on a somewhat an arbitrary decision on my part that 10 was about as many as we could handle, and so we tried to find the best 10 that we could that would most represent what was going to have to go on in an ATSC 3.0 environment. We were trying to have that many parallel breakout groups. As it turned out, with the people we had, We divided it into 2 groups of 5. The first group, Group A, really were the fundamental signal flows, and then the ones in Group B are the things that more or less depend on those fundamental layers. We developed the names and descriptions before we got to the meetings, and in the process of going through all this, decided that we needed to change some. So when you look at the list here, you'll see that there's one that's crossed out and moved elsewhere, and another one that came up. So we did video, audio, data as an essence form. So we have video data, audio data, data essence. Ancillary data, which was originally separate, we realized was going to operate pretty much the way data essence would operate, and so it was moved into the group on data essence. The group number 4, which was ancillary data, we decided that metadata was a better subject for it. It turns out that they did not produce a block diagram, but rather came back with a spreadsheet that provided some real insight into how metadata needs to be handled in a plant. An information layer, and that essentially is all the information that a receiver needs to get from the station to tell it how to receive the signal and what's there to be received. So, for instance, the configuration of the various parameters in the physical layer have to be sent so the receiver knows what to do, but also the viewer needs to know what programs are available now and going to be available. We consider all of that information. Content identification is identification within the plant in ways, for instance, using watermarks and fingerprints that would allow for automated confirmation of what's flowing where. Security, discussed earlier. Synchronization is things like lip sync and getting data in the right place at the right time. Closed captioning has to appear at the right time. There's other forms of data. If you're doing applications that have to run at specific times relative to a program, that also needs to be synchronized. And then management and monitoring is making the overall system run, and then distribution and redistribution is transmitting it and getting it to MVPDs and organizations like that. So we're modeling the complete ecosystem. We did it through thinking about 5 stages of the workflow, all the way from acquisition, production, post-production, through release and delivery, so network to affiliate, for example, and then emission, which we thought of as over the air, which is purely push, or it says here OTT, think broadband, which can be either push or pull. And then finally, the redistribution by other services. We thought about doing the block diagrams in 2 time frames. And those time frames are an initial implementation where we're trying to do this as simply and economically as possible to fold in ATSC 3.0 into existing plants that are designed for ATSC 1.0. So we want to be able to provide the same services that we currently provide and no more. Get it on the air, begin that transition. We called that an early implementation. Then the later implementation was, if we're going to do a full implementation of everything that ATSC 3.0 enables. Now, we recognize that probably no one broadcaster will do everything that ATSC 3.0 offers because there's so much. And they'll decide based on their business needs what they want to implement. But as long as we've covered all of the possibilities, then broadcasters can pick and choose what's right for their individual operations based on what they've chosen to put on the air. Okay. So in the report that we're working on, we'll look at the motivation, we'll look at methods, we'll look at conclusions reached if we get to any specific ones, and in particular provide explanations of the layers and their interactions and the touch points. We have a fairly extensive spreadsheet that shows all the touch points, for instance, and what signals need to go around, go back and forth between layers. Just using that as a checklist will help anybody building one of these facilities to really understand what they need to include and to make sure they've covered it all. We did this trying to avoid what all the other committees are doing, where it's a meeting every week or two for an hour, hour and a half, 2 hours, because they go on for a very long time. Certainly in those groups, there's much more detail that's got to be dealt with than what we were doing, and in those groups there's a lot more development going on. We were trying to, as quickly as we could, gather all the information and get it in a usable form. So we held 2 3-day sessions hosted by Sony in San Diego back in the fall, and we're fundamentally using all that information going forward. So let's take a look at the block diagrams quickly. This is, I'll just run through the layers in the order that I listed them before. Does this have a pointer? I don't see one. So if you look in the upper left, what you'll see, this is the video and this is the early implementation. What you have in the upper left is essentially a standard video routing switcher, SDI, HD SDI kind of routing switcher. There are a bunch of physical processes that go on between the input and the output. Sources come in from the left, they get routed through the processes, and then they go out the right side, and they end up in ATSC encoder and heading out onto the air. And there's some amount of other outputs that are used. And I'm sure you can't read this any better than I can from this distance, so I'll just try and give you overviews. The important thing is in the green block on the right is a listing of all the various processes that are implemented in a plant of this sort. And they're all done as physical processes. In the bottom of this diagram is an IP router that shows the early stages of IP distribution. And between the two, there's a converter that takes you from the SDI world into the IP world. When we move forward to the next period, when we're trying to implement more of what's available in ATSC 3, we still have the SDI, it's still feeding an ATSC 1.0 output, but most of the actual signal flow is now going on in the lower half, where in the center you've got, or in the big block, you've got a software-defined network that's assumed to be there to handle all the IP routing. And all the processes are running in servers. So this is, looking forward, if you were doing this, here's how you would do it. And all the processes that are on the right are, in the green block, are now going on in that block inside the servers in the lower left. And the outputs there are the outputs that you need to get to an ATSC 3.0 encoder. Looking at audio, the perspective that the audio group took was to look at the various sorts of inputs that there would be. They assumed effectively a crossbar switch, crossbar in the figurative sense, as obviously be on an IP platform ultimately. But looking at things like news sources and network and so on. And then on the right-hand side of that switch is the encoding that needs to go on to feed the ATSC 1.0 encoder, the 3.0 encoder, and the internet feeds that are anticipated. If we look at data, the expectation in this case was that there would be a central device that would have inputs on one side and outputs on the other, and it would do most of the manipulations that are necessary. That ends up being what's labeled as a facility down at the bottom with connections to the internet and the like. There's also a device in there that's intended to, on some diagrams was labeled "the magic happens here." It happens to be given a name that, for those of you who remember War Games, the movie, it's labeled WOPR. So this is the table that the metadata group produced. The most important outcome from this was that metadata that's necessary for rendering the content needs to travel with the essence. So if you've got to have the metadata there in order to be able to reproduce the essence, whatever that essence may be, video, audio, data essence, then that metadata should travel integrally with the essence. If you have other metadata that is not necessary for presentation, let me call it, of the essence, then that could travel on a separate path. The information group looked at what the sources were going to be of the various types of information that will be necessary, and then looked at where it was going to go, and fundamentally said it's all going to have to flow through some device that is knowledgeable about how to structure it. So, for instance, you might be getting program schedules from a service of some sort. You might have some amount of program schedule information being generated locally that would then have to be formatted into data forms that could be transmitted over the air to provide service guides and program guides and things of that sort, and also fed into automation systems and the like to make sure that they put the programming on the air at the right time, traffic systems and the like. The Content ID looked at, as I mentioned, at things like watermarking and fingerprinting and where those would be inserted within the facility, where those would be extracted so that you could confirm what was passing through, and also how it could be fed out to the encoder in some sort of encoded form, embedded form, so that those needs would be met as well. Security primarily recognized that there would be local, regional, and national providers of control. And some content would only be managed in a local region. Others would be managed on a national basis. And there had to be a way to get the various rights and permissions to facilitate that. With respect to synchronization, there was an alignment function, which is the slim vertical box that's in the third column over in this diagram. So flowing through that are video, audio, data, and information in the various forms, but they have to be aligned in time at a certain point. Then they can be fed into the ATSC 3.0 encoder. So the assumption here is that everything is aligned before it reaches the encoder. The encoder doesn't have the responsibility to do that. It has a responsibility to keep it aligned in whatever time relationship those layers had when they reached the input of the encoder, but they have to be aligned before they reach the encoder. This is probably the most complex of the diagrams. Basically, it says you need something in the middle that can look at every other layer and understand what it's doing, and then provide output to every other layer as to what needs to happen. And this is, for example, if you make choices among the variety of parameters that are available in the physical layer, they will set up a group of, let's call them channels, PLPs. And each one of those has a different data capacity. And you need to know which of the various IP streams is going to go into which of those, and have what level of robustness. And you want to make sure that you don't overfill the channel, but you fill it as much as you can. Something's got to manage all that, and that's what this is all about. So it's a recognition that probably with that many choices, ultimately you don't want to have to be manually setting up everything the way we do it today, if you're going to take advantage of all of the features and capabilities that are there. And then finally, the last one is the distribution and redistribution. In this, we have segmenters for over-the-air and segmenters for broadband. If you think back to the dash descriptions earlier, you're creating small segments of content that are played out one after another. So this is where that happens. There's also some recognition of the need for statistical multiplexing in some cases. And then you can see that there's time information coming in where it says UTC, that's a representation of time. In other cases, GPS is a representation of frequency. There's a segmenter, as I mentioned, for broadband. That goes into an origin server that ends up as an origin server and file server, and that goes into the internet so that you can do things like repairing content that didn't make it over the air. So it's got to be synchronized. In the lower right corner is the redistribution function, and there's a box that talks about legacy and another box that talks about add insertion. And then the new thing that came out of this was an IRDE. Many of you will know an IRD, an integrated receiver decoder. An IRDE is an integrated receiver decoder encoder. So it's the concept that you might receive ATSC 3.0 over the air and have a way to convert it to ATSC 1.0 if that's what the redistributor needs for its plant. We've heard from cable operators, for instance, that they want ATSC 1 to continue to be delivered to them, at least in the early stages, and so that's an understanding of how you would do that. So now, how are we going to put all this together? Here's what it'll look like when we get to the final version. This is an overall diagram with all of that included in it. And if we peel back the layers, there's video, there's audio, there's data, there's the information layer. Notice there was no metadata layer. There's the content ID, security, synchronization, management, and the distribution and redistribution. And it all goes into that overall diagram. And so that's kind of what we're working toward, to make it possible to dig down and see the relationships between all the layers and to understand where these touch points really matter that I was describing to you earlier. So if there are any questions, I'd be happy to try and answer them. Guess not. Okay. Where? Oh, over there. That's not the case, Pat. We can talk about it offline, but it was well understood that IEEE 1588 and the whole SMPTE time development process was in play.